Hello everyone. Today we are going to review the node analysis method. In order to do so, we are going to write several steps. Step number 0, forget variables and knowns. Step number 1, identify the node, paying special attention to the ground node. Step number 2, transform your circuit to frequency domain. Step number 3, choose a node. This node is going to be the node that has the biggest voltage in this time. So it's going to force all the currents go out of that node. We are going to write one equation per each node in order to make a system of equations. Step number 5, solve the system of equations. And step number 6, solve the variables. The circuit that we are going to be solving is this one. It's an AC circuit with a couple of current sources. Step number 0, forget the variables. Okay, I'm going to erase all this. Step number 1, identify the nodes, paying special attention to the ground node. So I have my node alpha, my node beta, and my ground node. Step number 2, transform your circuit to frequency domain. This side I'm going to have 10 angle of 25 degrees. In the other side I'm going to have 25 angle of minus 90 degrees. I have J15 in this inductor and minus J8 in this capacitor. Step number 3, choose a node. Assume that the analyzed node has the biggest voltage, so it forces all currents to go out of that node. Node alpha analysis, and we are going to apply the Kirchhoff's current law in this node, and we can observe that I only have one single current that is entering the node. This is going to be the 25 angle of minus 90 current. So this one is going to be equals to the rest of them that are going out. For example, V alpha over 10. Then I have B alpha over minus B beta, sorry, over 20. Then I'm going to have B alpha minus B beta over minus J8. And that's it. We're going to analyze now the beta node, assuming that is the one that has the biggest voltage and all the currents are going to go away from that node. Node beta, so B beta minus B alpha or minus J8 plus B beta minus B alpha over 20 plus B beta over J15, and also the current from the source is going out, so this is going to be plus 10 angle of 25 degrees. All this equals 0 since there are no currents entering the beta node. Step number 5, solve the system of equations. I'm going to type Csolve 25 angle of minus 90 equals VA over 10 plus B alpha minus B beta over 20 plus B alpha minus B beta over minus J8. Then I'm going to type AND, A and D, in order to separate equations. And the other equation is going to be B beta minus B alpha over minus J8 plus B beta minus B alpha over 20 plus B beta over J15, and this is going to be plus 10 angle of 25 degrees, and this is equals to 0. Then I'm going to type comma BA comma BB, and that's it. I have my results here: 222.14 angle of minus 70 degrees, and B beta 279.36 angle of minus 63.37 degrees. Okay, I'm going to write this in my solving document. So this is going to be B alpha equals 221.143 angle of minus 70 degrees, and B beta equals 279.368 angle of minus 63.3 degrees. Step number 6, solve the variables in my circuit. Okay, so my variables are going to be BA, IB, IA, and finally BB.
Okay, BA is the opposite to B beta, so they're going to be having the same magnitude in here, 279.368, and I'm going to multiply my B beta. I'm going to grab it. That's it. Times minus 1. So the angle is going to be 116.6 degrees volts. Now for BB equals B alpha minus B beta. I'm going to graph my solution and I'm going to subtract this. That's it. And the result is 64.126 angle of 140.3. IB is going to be minus B beta. I already have this quantity and I have to divide it by J15. I'm going to grab this and all the division here. That's it. I have it. 18.62 angle of 26.6. 18.6245 angle of 26.6. Finally, IA, that is equal to B beta minus B alpha over minus J8 I already have B alpha minus B beta, and I just multiply this times minus 1. That is going to be exactly the same that if I type only IJA,
and my result is going to be 8.0157 with an angle of 50.3 degrees. Thank you very much for watching. See you next time.